So in this video, we'll quickly look at how do we take any number of observations, for example, from a normal distribution, and then see how we can find the nearest neighbors. So I'm taking two variables, x and y, 200 observations with different means and same standard deviation. And we can quickly create a data frame using this. So I got x and y, and then I'm creating a data frame called a df1, which bundles this together. And once I do that, I will quickly rename the columns as usual. And once I do that, you can see how the data frame looks like. And once I have a set of observations, instead of doing the conventional k-means clustering, what I would do is I'll do a k nearest neighbor. So essentially the command for this is knn, and I'm storing this in a variable called nn3. So k nn, and then I'm passing the data frame, which is df1. I will pass on the number of points a core subsection would have. For example, so in k-nearest neighbor, the concept is when we look at density-based clustering, it is about core elements, border or fringe elements, and then the noise. So what I'm doing is I'm trying to find, so I'm basically extending the same concept, but limiting that to the number of nearest neighbors. So when we do density-based clustering, we're looking at how many points that need to be in the neighborhood. In this case, because I'm looking at the neighborhood in isolation, I'm just taking the three nearest neighbors, and I will specify k equal to 3. And then I would have to specify the distance. How do I calculate the proximity? So that is Euclidean distance in this specific case. So search would be equal to dist, and that's how I will get the k nearest neighbors. And so this is how I get this object for 200 observations. And then I can quickly look at how my observations have been populated with the corresponding neighbors. So for each observation, I would have 3 nearest neighbors based on the Euclidean distance. So the proximity will be calculated based on the Euclidean distance. And once I do that, I'll quickly visualize this. And this is how it looks depending on the proximity. For example, some points are closer to each other, some points are distant. And that's how this is kind of a closed graph, which basically connects the nearest neighbors for each observations. And that's how, since we're looking at 3, you'll see mostly the triangular structures. If you change the number of neighbors to 5, we will see a more evolved structure, maybe a pentagon or a hexagon and so on. That depends on the distance, the relative proximity of points, and the way the points are distributed in space. So we have taken the 3 nearest neighbors and we have plotted the graph. And once we do that, we can also quickly take a look at how do we highlight neighbors for any particular given point. So what I've done is I've basically tried to filter the color as well as the shape of the individual observations. And this is how it looks like. So let's quickly minimize this. So once I select the observation, in this case I've selected observation number 1, and this is how I see the 3 neighbors for observation number 1.